Okay, so you can try tomorrow morning. So if you have any problem in joining that, you can just mail me. My mail ID, I guess most probably you have. You can just mail me regarding that. Or but I'm pretty sure everyone is allowed to join that. In the starting 2-3 sessions, there was a issue in the sense that only the term students was allowed, but after yesterday, I guess the day before yesterday, I've seen that there are so many like people who were wanting to join. Those were like the qualified students. Those are not the term students. So I have already allowed everyone. So now whenever I'm sending you the link, like the link that are there in the calendar, anyone can join it with whether you have a IITM or like mail ID or not, you can join it. Okay, so I don't think so there will be issue tomorrow morning. Okay, I'll also be there for some time and I can check it whether you are able to join, because whatever in the last session I was there, and I was able to see that the people whose mail ID was not, so basically the person without official mail ID was also able to join, so there is no issue in that.
Sir, what are you going to cover in today's lecture?
So we'll solve some problems. Okay, I'll just start in 2-3 minutes. If you have any other query, so that query that you were having in the last session, most of you were not able to see the week 2 content. Now is it visible to everyone? Week 2 content.
Yes. Yes, sir.
Yes, sir.
Okay. And also, so there was some issue regarding the graded assignment also. So some people are not able to submit it. So that is not the like issue now, right? So everything has been resolved.
Yes, sir.
Correct. Yeah. So the terms you can ask it on the discourse also. So now you can get the reply on the discourse also. In the starting for some 2-3 days, there was some difficulty, some error, but now everything has been resolved, so you can ask on the discourse also. There you can get your query resolved.
Can anyone send me the Discord link, please?
Yes,
Sure.
sir. How can we join on the discourse?
I guess if you don't have the like the mail ID, you can't join. Like the term, like the qualified students can't join it as for now. Okay.
Yeah.
Then after the 4th week, you can join it, but the term student can ask their own.
Okay.
The
Okay. Okay.
qualified
Thanks.
students can join this session and the session, the TH session. Mostly the session you have some four sessions per week plus 3 sessions. So you have altogether 7 sessions. You can join it anytime and can like the scheduled time and can ask it out. Okay.
Yes, sir.
Till
Oh, sir.
quiz one, I have increased the number of sessions, so that will be good for the people who doesn't have the who can't
Yeah.
ask. Yeah.
Yes,
Sir,
sir.
there
Some
are
issue-related functions, some problem related to function, example of the function.
Yeah. So I'll start solving some problems. In the end, if you can wait it, you can wait and get resolved your doubt. So whatever the
So
the
there's a
plan
doubt
session,
regarding
according to the
practice
plan session,
assignment.
I'll discuss those questions.
excuse me, sir.
In the end,
Sir?
I'll wait for some time, and then if you have any other query, I can just solve that. Okay.
Sir, there were lots of questions and functions about one and onto or bijective, surjective, and injective functions. There were lots of questions and
Hello.
the process to solve the questions of bijective, surjective, and injective functions. I don't know how to solve them. I mean the major process for solving that questions or the process for one and onto. So please clarify that question.
So some questions
Yes,
I
sir,
have.
I have the same problem.
Okay, some questions I have. Some questions regarding injective and bijective, surjective. We'll solve those questions also. Okay, so I'll just start now the session.
Hello.
You have
Hello,
to
good
solve
evening,
those
sir.
questions.
Hello.
Okay,
And
sir.
okay,
Excuse me, sir.
yeah.
Excuse me. So, I was solving the practice question for week 1, and I just noticed that some of the answers were not marked in the question paper. Like in the PDF session, like answers were given in the PDF. So there the answers were given, but when we are doing on the portal, it was not given, and it was
Which
showing as a
practice?
wrong answer.
Which
Yes,
practice
sir.
assignment?
In the practice assignment 1, sir, week 1.
So earlier
So
there were
we did
5
not
practice
get the
assignments, but
so
now
we
there
did
are
not
only.
get we
I
did
was
not get the practice assignment solution, sir.
So the
practical assignment solution was given as PDF in the like before the questions, but when we're doing in the portal, some answers were not given, and when we are marking that answer, it shows like you have given a
Incorrect
wrong answer.
answer.
Yeah, incorrect answer. Yeah. If
Okay,
someone
okay.
have did the practical,
But
I
we
mean
have
practice
not
questions,
even
then
answer of PDF. The PDF.
in the same week, I mean same practice assignment. I guess in the above it was written as like something is given as PDF. Something they have
Download
added
PDF.
it there. Pardon?
Okay, okay.
Download PDF.
Yeah,
This
download the question PDF. In that answers were given
this practice. See,
In my
everything
for
assignments
week one.
yeah.
in week one, I don't have practice assignment 1.2 and 1.3.
Yes, so,
I
There's
have
so,
only
so
two
no
earlier
practice
there were
assignments.
5 practice assignments, but now there are only 3 visible, and in which practice assignment 1 and 1.1 are same.
that is
I
totally
have only one
so
visual in my
those are same
portal.
questions. Don't worry about that. Just the randomized form. Okay, the number numerical values has been changed. Okay, so you don't have to worry about those things. The questions almost will be same in every portal. Okay, don't worry about that. So only the questions maybe 1.2 or 1.3. Only the jumbled number. If somewhere the numbers is x equals to 2, so the other places the number can
So
be
what?
different.
So what about the answers? When we are
Sir,
like when we are giving the
Okay,
answers, like
I'll check that and I'll let you know in the morning. I'll meet again, right? So I'll let you know after checking this. Okay.
the morning when you have the lecture. I mean when we have the scheduled lecture timing.
Tomorrow 10 to 11 you have.
Okay, 10 to 11. Fine, sir.
So that maybe it's not there in the calendar, but after the session, I'll fix that. Okay.
So what about the link and link for the session?
Everything will be there in the calendar itself.
Okay, fine.
Sir, is this session recorded, sir?
Yeah, it's recorded. So let's start now. I'll just share my screen.
sir, I can't, sir, I can't, I have only one practice assignment in week one, sir.
That's totally fine. This is what I was saying. If you have 1, 2, 3, that's totally fine. Okay. Even though if you have one, it'll be like same. Like if you have somebody has 2 practice assignment, the questions will be same. Only the numbers are jumbled. Okay. So don't worry
Sir,
about it.
Okay,
you
sir.
mentioned about download PDF, right? Where is that? I'm not able to find.
Okay. So in the
Yeah, there's no PDF for
content
the
is there.
practice assignment week one, which is written as non-graded. There's no
Yes, sir.
solution PDF for that.
Click here to view the question PDF. Okay, there is a link there. Yeah. Yeah, I got it. So that is okay. The first time.
So
So
there
you
was
mean to? Okay, that is yes, that is there.
so
Thank you.
every time we submit the practice assignment, the questions change.
This is what I was saying. The questions will be same. Only the values will get jumbled. Okay. So that is has been done because many of the people generally copy. Okay. So that's why every time
So
for the
there
okay, sorry.
says that the practice assignments are bonus
This
exercise
is for
and
the
may be
okay.
graded later on, but every time
Can we actually do
every time I
something
submit,
like instead of
a new sheet
discussing?
comes up and it says that you have to submit the practice assignment again.
So if you are just opening one, okay, you
Yeah.
just solve those and submit it. That's it. And
Okay.
for practice, you can go and like you just have to submit once.
Okay.
Are the
Or
practice
you can submit
assignments and
Sir,
graded
sir,
assignments question
So,
for the
enough for the
sake of time,
qualifier
can
exam?
we actually focus on
whatever you
sir,
are
real
submitting.
problems?
The last submission will be taken as your
okay. And so
mark.
will the marks as well matter, like how many questions we are doing it correctly and how many wrong, even in the non-graded practice assignment.
So the marks won't be coming. Only they'll show whether this like the mark thing is correct or incorrect in red or green. I guess
Yeah,
the
so only that.
overall marks won't be there. Yeah.
So graded assignment 1 is the one that matters, right? Finally.
Okay, graded assignment one. What can you repeat that? Graded assignment.
Yeah. No, graded
He is
assignment is what
telling
we
it
finally have to
graded
do before the
assignment.
deadline.
The deadline is second of
Yeah.
Feb. See, whatever anybody so whatever shown in the portal will be your final deadline date. Okay. Maybe sometimes like for see, I was aware that 31st is the deadline, but you told on the portal it is showing second. So second is the deadline. So whatever is there on the portal is the exact one. Okay.
Okay.
Many times it may happen that like they'll maybe reschedule the deadline or maybe they can give you some extra time. So that depends on the team how they are taking. But mostly it will be on the Wednesday every time. But if that is extended, then it's fine. You can just check it on the portal itself. But try to finish it before this Wednesday, like for the next weeks. And
Okay, sir.
so
Sir, I
let's.
just wanted to know when will we get the practice assignment solution? It's not there in the portal.
It will be okay. It's for week 1. It's not there. It will be uploaded. Don't worry. By tomorrow, I'll upload that.
Okay, sir.
Sir, is this
Every time,
vision session?
whenever the deadline will get finished, your submission, the graded assignment solution, practice assignment solution, everything gets uploaded once the deadline gets finished. But if you want for the practice assignment, you can I'll upload that practice assignment solution.
Sir, only the graded assignment marks are matter for the qualifiers, or
Sir,
we have
please
to
start the
do
class.
practice assignment also.
Sir,
Only the
please start the class. Half an hour wasted on this.
Okay, let's start the session. So I'll take the queries, whatever you have, you can just put it, and in the end, after the session, you can just ask me whatever the doubt, whatever the query you have.
Sir, can you repeat what did you say? How to start this site?
What? I'm not getting. Okay, I was just saying the graded assignments marks will be considered. What else I said? I don't know.
Sir, I have an issue. I
No,
have
sir, I'm
registered, but
asking
my
how to
current
start this site.
Sir is
What's
not
the
yet
code?
told that how will the site will start.
Okay.
so my current courses portal is getting showing blank. There's nothing in my courses and all.
Okay, try it in
What should I do?
incognito mode, or maybe there must do the hard refresh once from wherever
So I've
Google.
done it many times. Like it shows
You're
nothing.
not
And
able to open it, the portal.
yes, sir. Sir, my dashboard and
Okay,
the
you are a qualifier or a term student, like you have already took admission, or you are about to write the qualifier exam.
I'm a JE student. Like I've qualified JE.
What you can do is, okay, you are not able to open it. So mail me your personal mail ID. Okay, so you can just mail me. Okay, do it personally. The mail ID you can just send me. I'll forward it to the team. They'll contact you. Okay.
I say your email ID. Can I get it, please?
No, you just in the chat box itself. You can directly send me your mail ID. Okay.
Okay, sir.
Sir, I got the Discord forum invitation, but I'm not able to join it because they're asking for the house name, and till now house is not allotted to us. Like,
Okay.
will they send again invitation link because they have sent 2 times?
Okay. So without filling it, you are not able to join it.
No, sir, I'm not.
Sir, in my case, I could able to join in the discourse actually without mentioning the house name. It's possible.
Sir, I
It is
did not
not
get any
mandatory.
It's not
invitation, sir.
mandatory. It's not a mandatory field in the form. The
Yeah.
name of the
You can
house.
join it without putting the house name also.
Yeah,
And
I didn't
later you
put the
can put it.
house name. I could able to join. Yeah, please everyone may check with yourself.
Okay, sir, I will check once again. Thank you.
So can we start the session?
Okay. Yeah. So we can start.
Anyone please share the join PD code? I don't see it anywhere.
So you don't have to join it. You can just short there itself. Okay. And you don't have to.
Okay, thanks.
Okay, so we'll just solve some basic questions in the starting, and then we'll go increase the level. So this is the first question that you have. Basically, you have a rational number. So some numbers has been given to you. Some real numbers is given to you. You can see the screen, right? You can see my screen, correct?
Yes,
Is
sir.
it visible to you?
Yes, sir.
Sir, it is visible.
Yes, sir. Yes.
Yeah. So you can see this. There are some 5, 7 numbers, and then you need to pick out which of the following are the rational numbers. Okay.
Yes, sir.
So you just solve it. Try to solve this problem. And nobody will unmute yourself and tell the answer. Okay. You just try from your side. Try to solve that. And then I'm just giving you some 2 minutes. Try to solve this, and then only I'll be asking you. So you don't have
Please
to
tell
write.
me the code.
Yes, sir. What's the code?
You don't have to join it from the join PD. You just solve it here itself.
Okay, sir.
Yeah. Don't have to join it there. Just solve it here itself. Yeah. Have you tried, everyone?
Yes,
Yes,
sir.
sir.
So, okay. What do you mean by rational number? First, tell me.
Any number in the form of p by q
P
where
by
q
Q
is
and
not
Q
equal
not
to
equal
0.
to 0.
Okay. So any number that can be written in the form of p by q. And what are the conditions that you will be applying on p by q?
Q is not equal to 0 and
Not
p and
equal
q
to
are
0.
integers.
Q should not be equals to 0. And what about p and q?
Integers.
And perfect
Integers.
squares.
Correct?
Perfect square is
Integers, sir. P and q are integers.
P and q are integers and q is not equals to 0.
Yes,
Then you
sir.
can say that then it
That is a
can be
real rational number.
rational number. Correct? So what about the
Yes.
2 to the power 1 upon 3?
Irrational number, sir. Because it cannot be represented in p by q form.
Sir, your voice.
Correct? So 2
Yes.
to the power 1 upon can you please mute yourself, everybody? Yeah. So it's almost same as so you are already aware of root 2. Okay, can you tell me about root 2 upon 1? What is this?
Irrational.
Root 2
Rational or
only.
irrational?
Irrational.
It is an irrational number.
This is also
rational
irrational,
must
right?
be perfect square.
Similarly, 2 to the power. So this is what 2 to the power 1 upon 2. So this is also a irrational number. Okay. Now tell me what about this number? Root 8 plus root 2.
Rational.
It's a
Plus
rational
8 minus root 2.
Rational number, sir. Because on simplifying we are getting 8 minus 2 which is equal to 6.
Yeah, correct. So you can write it like a plus b and this
a minus b.
a minus b, and you already know that this is what a square
minus b.
plus b square. Correct. So you can write
A square
it
minus
like
b
this.
square.
A
A
square
square minus
Or
b square.
Minus b square.
minus b square. Sorry, my bad. Okay, so this you can write it right. Correct.
8 minus
So
2.
this will be what?
Yes, sir.
So this can be written in the form of p by q, right? And p and q are
Yes, sir.
integers.
Integers.
And q is not equals to 0.
Non-zero. Yeah.
Correct. So the first number you can directly say that the first is irrational number. This is rational, right?
That is right. Yeah.
What about this number?
Rational.
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 Right.
How
So
sir it can
Filippo?
be rational?
Yeah. So what was that number? 4 point?
4.89.
Correct?
It's terminating.
No, this not this number gets terminated there itself. Okay. So how can you write it? If you have some 7.5, how can you write in the form of PYQ? Can you write it
75 by 10.
75 by 10.
75 by 10.
Correct. So how can you write this number? This can be also written in this similar form.
Yes, sir.
Because this is a
By
terminating, right?
removing the decimal, we can write it.
Correct. You can write it in this form. Right?
Yes, sir.
This is the form of PYQ. And those P and Q are both integers. And Q is not equals to 0. Correct? Is there any doubt in this number? Anyone?
No, sir.
Sir, if it's decimal number, then it's irrational number, no, sir.
What?
Sir, I have a doubt, but I am not in this doubt. I have a another expression which I want to confirm is rational or irrational.
Tell me.
It's
Wait for
root 8 minus root 2.
This number we solved it, right?
Sir,
No, sir, this not.
Next one is
question, sir, will be coming.
Root
Any-
8 minus root 2.
Yeah, root what?
Root 8 minus root 2 bracket close.
Yeah.
फिर दूसरे ब्रैकेट में रूट 18 प्लस रूट 2.
That's a part of our graded
Sir,
assignment.
this is
right?
graded assignment question.
It should not be discussed here.
We can't discuss, right? Okay, leave this. Okay.
I have a doubt.
Let's come to this
If it's
number.
a decimal number, then it's irrational, no, sir. Then how this 4.8799 is rational?
What did you say? Can you repeat that? 8 point. See, any
4.8,
number.
the last question.
See, any number, whatever the number you have in the form of decimal. Okay, if it is terminating, okay, you can write it in the form of P by Q. Any number, let's for example 7.5, you can write it like 7 by 75 by 10 or 6.5 or any number 3.957. So you can write it in this form, right? 3957 upon 1000. If it's terminating, it's getting ended, then you can write it in this form, right? So if you are able to write it, so what do you mean by this? Hey, please mute yourself, otherwise it will be very difficult. So any number, any real number that is written in this form, where you already know that Q should not be equals to 0 and P and Q are some integers, then you can directly say that. So just stick to the definition of the rational number. Okay, any number, if you are able to write it in this form, okay, where the condition whatever I have said is fulfilling, then you can directly say that this is a rational number. Okay.
Sir, but the value of pi and e, they are irrational?
Yeah, pi are irrational because it's not getting ended. Okay, whenever you will divide that number, that's not terminating. Okay, that's why it's a irrational number. Did you get my point? Whatever I was.
Yes, sir. Yes, sir.
Because
Sir,
values after decimal you have some values. Those are given, right? It's not like it's going to infinite.
Sir,
Okay?
can we write pi
Those
as
value
22 by 7?
What?
Can we write pi as 22 by 7?
Yeah. No, that's not the exact value that you
No, but that would not be a complete pi representation.
Yeah, that's
Pi,
not the exact
that's an
value
approximation.
you write it. But approximation you can write it. You'll get
Excuse me,
something
sir.
like 3.1 for some 1 for 2 something. It's like
Sir,
yeah.
how can we know if a number is terminating or not?
Okay, leave that. If it's not been taught, I was just saying that after decimal, if you have been given some exact number, right? That, for example, this is 4.973. Okay, so after decimal, so some three numbers has been given to you. So these you can write it in some PYQ form, right? In some numerator, there can be some value. Denominator, there can be some value. And after doing the like division, you are able to get this value, right? So you can
Sir,
write it in this form also. If you are able to write it in this form, where all the other condition is been satisfied, you can say directly it's a rational number. Okay.
sir,
Okay,
2.9
thank
bar
you, sir.
is a rational number. 2.9 bar number bar.
See, and again in the terminating, if you are putting C, so termination also there are two types of termination. If it's a repeating one and if it's a non-repeating, those are not taught. So that why are you asking me this question? I don't know. But if it's a
Okay, sir.
terminating, it's a repeating, then it will come under the again rational number only. But it's not terminating and the repetition is there already. Okay, so then irrational number. So they are basically terminating. So you have to check after if it's a non-terminating, it's a reoccurring or not. Okay, so that I don't think so that is taught. Okay, but basically this is what happens if you have some real number, right? So it can be rational or irrational, right? And again, you have to check whether whatever the number that I'm given to you, whether it's a reoccurring, like the repetition is there after the decimal, or if it's a repetition plus the terminating, or it's a repetition, non-terminating, or repetition. So based on these two values, you can point it out whether it's a rational or irrational, but it's not been taught, so you don't have to worry about those things. Okay.
Sir, I wanted to ask one thing.
Yeah.
Sir, is zero a natural number?
See, here it has been taught to like what has been taught natural zero as a natural number. So you have to take zero as a natural number only. Okay. Because
Sir, but in school I was taught that zero is whole number and from 1 to 3 only it is natural number.
you can leave. You can like, see it depends on the many of the books will tell you zero as a natural number. Many of them won't take zero as a natural number. But here we'll be using Python and a very like coding languages, and also it will start basically from zero. Okay, so that's why we are taking. Okay, so you don't have to worry about that. The professor has told zero as a natural number. You have to stick wherever you are solving a problem. You have to take zero as a natural number only. Okay, this is what you have to stick with.
Sir, in one of the activity question, it was given that the set consists of natural number less than 5. So I took 0, 1, 2, 3, 4, 5. But in the answer, it was only given from 1 to 5. So if it will be given that natural number is consisting of 0, then only we will take the 0 as a natural number.
Here
Yeah,
you
sir,
have to
that
take
question assignment is there,
supposed to
sir.
take zero as a natural number. Okay, it's given or not doesn't matter. You have to take zero as a natural number wherever you're solving the problem. I don't know which question you're saying. I need to check that whether the solution that you have made was correct or not. That I need to check. Okay.
Zero is important.
Sir, what about product sum difference of rational numbers and irrational numbers?
What?
What is the sum and product of an irrational numbers? Two irrational numbers, if I take product or sum, the result will be irrational or rational?
It depends on the number to number. If you'll give me the number, then only I'll be able to say, right?
Say pi minus e.
So can we do the questions? After the question discuss?
Yeah. So this one I was just saying you. Okay, okay, you can just wait in the end. I'll discuss those. So this I was saying you in the starting. You can just write it, but it's not important at all because it's not been taught terminating, and then it can be non-terminating. But there should be something more. Okay, there should be something more. It should be reoccurring also. If it's not, then it will come under this not terminating plus non-reoccurring. Okay, so this is what the basic structure of the real number comes. I guess this terminating and reoccurring has not been taught. So if somebody knows, that is fine. If it doesn't, no problem in that. Okay. Okay. So what else was left? So all the numbers has been done. What about this number?
It's irrational.
Value is 2.
Sir,
Yeah,
it's
two,
a rational
right?
number क्योंकि our after evaluating we get
Rational.
2.
Yeah, you can evaluate this root 2 minus 1. You can multiply. So if you have been given some number, you can do. If you are multiplying something in the numerator, you can multiply the same thing in the denominator also. So there's no problem in that, right? If you have something like 5, right? If you're multiplying, this is 5 upon 1, so you can multiply 2 here also, you can multiply 2 here also. It will be 10 upon 2, and then again you can get 5, right? So if I want to apply again root 2 minus 1 or plus 1 here and root 2 plus 1 here, that is not going to make any difference in the number, right? So what are you going to get it here? So if you are multiplying this number, what will you get? If this is again, you can do it like this: a minus b and a plus b. Again, this will be a square minus b square, correct? So root 2 ka whole square minus 1. So the denominator part will be 2 minus 1, correct? Whatever the numerator part, what are the calculation? If you are doing the calculation, what the value that you will be getting?
Root 16 minus 2.
16
Plus root 8.
Plus 8 plus 8 or root 8.
Root 8 minus 2 root 2. Minus 2. And we can evaluate root 8 as 2 root 2 and it will get subtracted.
And then you are left with 4 minus 2.
Yes.
Is there any problem in this? Any issue in this? How did we came from here to here?
No, sir.
Rational number.
Anyone is having any issue?
No, sir.
Sir, yes,
No,
sir.
sir. No, sir.
Hello.
Yeah.
Sir, if we use the calculator, then we are getting irrational number only, no, sir.
What are you getting? Irrational number. I guess you are doing some maybe
Yes, sir. No, sir. No, sir.
calculation mistake you are doing it.
If we use the calculator, we are getting irrational number.
Okay, so how are you doing that? If you are using the calculator, okay, here you putting the values of root 2. What is the value of root 2 you are putting there?
No, sir. No, sir. It is rational only. Even using calculator also, you'll get rational number.
Yes,
Yeah,
sir.
using
It's
calculator it's coming
rational
to
only.
Even though no, I'm just want to know how are you putting the value of root 2 there? Directly root 2 or you are just putting okay 1.41 something you are putting?
No, sir. Directly root 2.
Then though you'll get a rational number.
maybe see if you miss the brackets.
Maybe that can happen.
Yeah.
Okay.
No, sir. I'm getting the value of 0.41421.
What is the value you are getting?
0.
No, you'll be getting something. Maybe some okay, you're putting in the calculator. I don't know how are you using the calculator.
Sir, exactly, you'll get 2, sir. I used it.
See, you can write it as 2 root 2 minus 2 upon root 2 minus 1. If you are taking 2 common, from there this is root 2 minus 1 upon root 2 minus 1. So directly you are getting 2, right? How can you get 10 upon 2 as something else? Like it will be same, right? Even though if you are multiplying 2 upon 2, you'll be getting 20 upon 4 as 5 only, or you are calculating 10 upon 2. Be same. So here also it's same, just 2 you are taking the common and will be left with 2 only, right?
So some technical issue with the meetings.
Maybe that can be the issue. Okay. And the last one is, this is pretty simple, root 48 upon root 27. So this is also, you are able to calculate it in the form of some rational number, right? So this is also a rational number because you are able to simplify that upon in the form of P by Q, right?
Excuse me, sir.
Yeah.
Sir, I have joined now. I don't know that how to submit the answers. Will you please instruct me?
No, it's like normal, yeah. So that's why I was thinking, week 1 I'll be just taking normally. From week 2 I'll be doing in joint PD. Okay, so it's normal on the PDF only we are solving. You don't have to. You just have to solve it with pen and paper, and then I'll ask you the answer. Okay.
Okay, sir. Thank you.
Yeah.
So it will result in minus 4 by 3.
Minus
4 by 3 after.
Yeah, the simplified form of minus 4 by 3. So this is a rational number, right?
Correct.
Very good evening, sir. Excuse me,
Yeah.
sir. Very good evening.
Good evening. Good evening.
Sir, just help me. Actually, I am not able to see my course content on my dashboard. So can you help me regarding this?
So you can just mail me your mail ID. Okay, do it personally. You can just personally mail me your mail ID. I'll check that. Okay.
So can you provide me the mail ID, sir? Your mail ID.
No, you can just write it in the chat box itself. You can just go to the chat box. You can just message me personally. Your mail ID.
Already I have forwarded you 2-3 messages regarding this on the chat box.
Okay. So in the end only, I'll collect the mail ID and then I'll forward to the
select
team.
the IIT Madras host.
Yes, sir. Same
Otherwise,
issue.
Already selected. I already selected the host and send it the same message to the host.
okay.
Okay.
So
No
kindly,
do it to
kindly
the
help
co-host.
me because actually not able to see any content, so not going to through any content.
Okay,
Try
that
with Cognito tab.
Yes, sir. Same issue.
Yes,
I don't
sir.
know
So,
how it is, but most of the people are able to. You just try it with incognito, hard refresh it. Maybe you have some cookies. I don't know what
Yeah.
is the issue, but maybe
Yes,
because
exactly. I was having the same issue, and then
Yeah.
I had to clear the
I
cache,
also
and then
face. I
sir,
also
so
clear
face
the
same
cache
issue
and
with
clear the
sir,
history
so
all.
many
Use the incognito.
like
Like
user.
Easier.
Yeah.
Chrome has this
Incognito.
issue. Chrome has this issue. Like I
yes,
have this similar issue,
On the
and
Google,
when I
some
reset
function will not
Chrome
show.
settings,
No,
then
sir,
it
I'm
was working
using
again.
Microsoft Edge. I still have this issue.
just
speak
maybe
one by
try
one.
on.
Please try resetting or using another browser. Maybe
Issue, you can
something
just
is
mail me. I'll just forward that, and they will take care of. You can just forward the mail regarding this to the support team. Also, they'll take care of that. Mostly, they take care of this. These are all issues. Okay, regarding to the portal, I can just forward your mail ID. That is what I can do
Sir,
maximum.
which mail ID? My
sir. In the
mail
chat,
ID given by IIT.
sir, kindly provide the mail ID on the chat box so that we can send the messages. Please provide us on the chat box on which email we have to send the messages. Please.
Support mail, you must be having the support mail, right? They do the
It is also available on web.
portal also will be there. So support mail is like available in this mail. Okay, let's move to the second problem. Okay, so there was 4 numbers. Okay, so there's no issue. Okay, can you tell me about the complement of a set? What do you understand by the complement of a set? Okay, can you please mute yourself? Whoever is there, please mute yourself. Okay, so you are already aware that if you have been given some set, right? Let's for example, set you have. Okay, and this is the bigger, like it's a universal set, and A is a small part of that set A. And then if you have to calculate the complement of that, so you just have to remove this A part, the rest remaining part are the A complement. So this is how you represent the A complement. Okay, so this has been given to you. And if you have to do so, I'm just going through a brief idea about the concept, and then I'll give you the questions. So there is some questions regarding that. And set subtraction is pretty simple. You can see the subtraction. A minus B is basically the content which are there in A. The content which are available in A but not in B. Okay, this is A minus B, you can see. Okay, this is A minus B, and this is the portion. The yellow area, you can see that these are the portion, those are not in B, right? If you see that A minus B is basically what? This the portion, those are available in A but not in B. This is how you present A minus B, set subtraction. And then you have the intersection. If you are going through A union B, that means all the elements which are present in A or B. This is basically OR.
Can you explain again set complement?
What?
Set complement. Just a
complement of A complement C. Let's for example, you have some bigger universal set. Okay, this is rectangle. You can think of as a universal set. And if A is a small set, okay, so if you have to calculate the remaining portions, so A complement is basically the elements which are outside A. So this white area you can say directly as a complement, okay, which are not present in A. Those are A complement. Okay, so the set of all the elements which are not in A. Okay, you can directly say that. From the Venn diagram also you can depict that this whole area is A complement apart from this black area that is present as a set A. Okay, is it clear now?
Yes, sir. Yes, sir.
Yeah. So now you can see that A in union is basically all the elements which are present in A or B, and intersection is all this the area which are common in both. So this is basically AND. Okay, so this is basically and this is OR. So you can see that this area, the green area that I have indicated, basically that is A intersection B. Okay, those are available in both the sets. If A, this is represented like this and B represented like this, so the area which are common in both are basically called as the intersection. Okay, and you represent like this, A intersection like this. So there's some formula that we can go through later. Now you have a question. So basically I have given you three sets. One set is M, one is S, one is C. Okay, and all the values has been given to you. Now you have to calculate the cardinality of some set M minus C. Can you tell me about the cardinality? What do you mean by cardinality?
Number of elements in a set.
Correct.
Number of elements.
The number of elements or item, whatever is present in a set, is called as cardinality of a set. Okay, now you have to tell me M minus C. Okay, you just go through this. I'll ask you after 1 minute. Okay, so it's 8:49. I'll ask you in 8:51. You can just try to solve it. Do not speak out the answer. Okay.
The cardinality is 2.
What did I say? You don't have to speak out. Okay. Solve. Okay, I'm giving you some options. Okay. Okay. Which of them is correct?
50.
Option A, sir.
Option A is correct, right?
A.
Okay, so you have to calculate M minus C basically. What do you mean by M minus C?
Element in M but not in C.
Correct. So which are the area? Can you tell me? Can you guide me?
10 plus 40.
10 plus 40.
Okay, which are the area? So this is the area. So M minus C, which are element which are available
10,
in M?
40, 70.
Right. So this can be the area, right?
Yes, sir.
Correct. These are the elements which are present in M but not in C. You can see that this area was there in C, right? This yellow area, which were common to M and C both, but that we have to exclude because we can't take that area because we have to calculate M minus C. So the areas or the sets, the available elements which are present in M, not in C. So that's why the green area will be the answer. So you can see that 4 plus 10 plus 40 is the green area, right? So you can directly write it as 50. Correct? Is there any issue in this?
Yes, sir. Excuse me, sir.
Yeah.
So I was confused, like 10 and 40 are cardinalities or these are elements. So like I was considering.
Just read the question.
Okay, okay. Sorry,
So
sir.
everything, yeah. So everything has been given in the question. So the number that has been indicated are the basically the cardinality itself. Okay. So you don't have to worry. So now come to the okay. So come to the second part of this. You have to calculate this one now. M union C altogether intersection with S. Okay, first tell me what is the area of M union C? What is the value of M union C?
70-50.
70-50.
So M is basically this area. And you have to take the union with C. So this is C, right?
Yes, sir.
Correct. And now I need to do the intersection with S. So which are the areas? If I have to do the intersection with S, which are the
40, 50, and 60.
40, 50, and 60.
correct. So this area is the common, right?
Yes, sir.
So the blue area that I have marked is common. What is the value you'll be getting?
150.
Sir,
150.
union
150.
Sir, union only 70-50, right?
No, union would be 10,
That
40, 70, 50,
Intersection.
60, and 30, and the intersection would be 40, 50, and 60.
correct. See, what I was saying is
10, 20, 30 to 70. No,
first I told you to calculate M union C. So M union C, you can see directly the whole yellow color that I have marked. Okay, so you can see that. This is the whole yellow. Okay, the total one is M union C. But if I have to, after doing this M union C, you have to do the intersection with S. Okay, so the set that has been given to you, the intersection with S, you can see that the area which are very common. So you can represent in some other form. So the green area is basically the M union C intersection with S. Okay, and that is basically what? 40. You can see that this is a 40, this is 50, and this is 60. 40, 50, and 60. Correct?
Yes, sir.
Yeah. Is it fine to everyone?
Yes, sir. Yes, sir.
Yes, sir.
Let's move to the next part. Okay, now we are coming to the next question. And now you have to calculate the cardinality of a set. I'll give you some, for this question, I'll give you some 5 minutes to think of. So you have been given a set S, A such that A is coming from the natural number. A is less than equals to 10. Now can you tell me what is the value that A can take here? You are already knowing that the natural number includes 0.
0 to 10.
0 to 10.
0 to 5.
0 to 10.
0 to
0
10.
to
Right?
10.
Then you have R1 and R2 be the relation from S to S. Okay. And that is defined here, R1 and R2. Now you need to calculate this. So first, write it. First, tell me the R1 and R2. Okay. You can take 4 minutes. It's like 8:56 till 9. Just think of what can you write. Write the whole R1 and R2. Okay. All the relation, all the sets, all the values that you can, all the elements of the relation R1 and all the relation, all the elements of the relation R2. Okay. And then only you try to solve this. So first you write it R1 and R2.
Sir,
Yeah.
where can I get this PDF, sir?
PDF will be uploaded. Don't worry.
Okay, sir.
Survive condition also.
I can't hear you. You can just write it in the chat box. Maybe there is some issue from your side, I guess. This PDF will be uploaded on this supplementary Sunday. Don't worry about that. Okay.
Very good. Now, do one thing.
Everybody, please mute yourself and try to solve this with pen and paper. I'll ask you. Okay. I can ask you randomly also. So just try to solve. Write it down R1 and R2 first.
Solved, sir.
Okay, just wait for someone, like everyone to solve that, okay, and then we'll start.
Sorry, sir. I lost my connection. Could you explain the last question once, the second one, like the answer, like after this one?
So you're asking the answer of the previous question?
Yeah.
Okay, so that was 150.
Graded question.
Okay.
This is a graded question.
Okay, no problem.
So solved it.
Okay. Yeah, 2 more minutes. Whoever has not solved, please try to solve it. Okay, is element 612 available
No.
No.
in
No,
R1?
sir. No, sir.
Why?
No, sir.
No, sir.
No,
It is
sir.
because
Next.
Because
A
S
is
is
equal to 10.
It's 10.
A is less
What
than
are the
10.
12
values that
cannot be there, sir.
what are the
S
values
is set of
R1
all
can take?
natural number less than 10.
One.
R1 can take
R1 can
0,
sir 6
0,
12
1,
Can be
2, 2, 4,
2, 4.
1,
3,
2 can be
6,
2, 4 can be there.
3, 6,
4,
4,
8,
8, and 5, 10.
5, 6, 12. Is it there?
No, sir. It
No.
cannot
No,
be there
sir.
because A
A is less than
7,
and equal to
14.
10.
is
A should be less than equal to 10.
Yeah. So this is not present, right? This is also not present. This is also not present. Correct?
Yes, sir.
Everybody
yes, sir.
clear with this? So you have a set S that S has A some A's where A belongs to a natural number. You already know that natural number can take 0. Okay, and A is less than equals to 0. So basically A is from what? 0 to 10. Correct? And then you have some S cross S, okay, as a whole. You can show that a Cartesian product of that. Okay. And then you are taking out some relation. So you have taken out some R1 relation and R2 relation. Okay. And so R1, whenever we are explaining, R1 can be, so we are just taking out XY, where? From S. Okay. And then there already, so there are some filter that we are applying where Y is equals to 2X. Okay. So whenever we are taking out X equals to 0, we are seeing that Y is 0. Whenever we are taking X equals to 1, you can see that because X can take from 0 to 10, right? And Y also can take the values, but Y depends on X also. So if you are putting X equals to 0, Y is from here. So Y is equals to 2X, right? So if you're putting X equals to 0, you are getting Y as 0. Similarly, if you're putting 1, then you are getting 2. But after that 5, 10, you can't put the, if you are putting the value of X as 6, that you can put it, but you can get the Y equals to 12. That can't be present in the set, right? So that's why we can't take 6, 12. So we have to stick our values from 0, 0 to 5, 10 only, right? So what is the cardinality of this relation?
4.
4, sir.
4.
6.
6
No, R1, I'm asking, what is the
6, sir.
cardinality of R1?
6.
6.
6, right? So there are 1, 2, 3, 4, 5, 6 values are there. Now tell me what are the values of R2? What is
0,
R2 here?
0,
1, 2,
1, 1,
1,
0,
0,
1,
1,
4,
2,
2,
4,
9, 3.
2, 4, 3, 9.
3,
0, 0,
1,
4,
1,
2.
1, 1,
1, 1,
2,
2,
4,
4,
3, 9.
3, 9.
3, 9.
Can I put 4, 16?
No, sir, because
No.
You can't
Less
put
than
it, right? Because
we can't
again the
put.
16 will come and 16 is not in our domain itself, right?
Yes, sir.
Sorry, range or codomain, whatever you want to say. So 16 is not present, so you can't take it. So now you have R1 and R2. If you are taking R1 union R2, what are the values that we'll be getting? If you are taking R1 union R2.
All value of R1 and R2.
Okay, what is the cardinality of R1 R2?
8.
8.
8.
8, sir.
So you can count the value. This is 1, 2, 3, 4, 5, 6. 6, right? And then what are left? 7. And then this is 8. Correct?
Yes, sir. 8.
Okay. Now tell me what are the numbers or what are the elements in R union R2, R1 union R2. So these are all the elements. This 1, 2, 3, all the 8 elements in R1 union R2. So like, and then you have to subtract the R2 from there. What are the values that we'll be getting?
6.
1,2.
Okay.
0, 0, 2, 4, 3, 6, 4, 8. 0, 0.
Complete set R1.
0, 0. How are you getting 0, 0 here?
It will start from 1, 2.
4, 8 and 5, 10.
Sorry, 1,
Basically,
1,
this
1,
is
2, 1,
C.
2.
R1 union R2 minus R2. So what are the elements present in R1 union R2? So and you have to exclude all those elements which are present in R2. Okay. So let's, for example, you were having some values, right? So all these 8 values you were having. Now you have to exclude all those elements which are present in R2. Okay. So which are the elements you will be removing? You have to remove 0, 0, right? Because 0, 0 is
0,
there in
0 and 2, 4.
Yeah, so you have to remove. I'll just mark it with some green. So 0, 0 is there. So you have to remove this. Correct? So this is removed. Right? Now 1, 2, will it be there? It will be there, right? So this will be there.
2,
2, 4 won't be there because 2, 4 is there in R2, right? So this will
sir.
get cancelled.
Yeah.
Correct? What about 3, 6?
Yeah.
Will be there.
This will be there because this is not present in R2. 4, 8 will also be there. What about 5, 10? This also will be there, right? So now you are left with how many numbers? 1, 2, 3, and 4. Correct? Yes, sir.
Yes, sir.
Everybody got this, right? Or do I need to explain it again? Yes, sir. Is this clear to everyone?
Yes, sir.
Yes.
I got
Yes,
it.
sir.
Yes, sir.
Okay. Yes, sir. I got it. So this is done. I have already explained you. Now you can.
Sir, answer 4, sir.
Yeah, answer is 4.
Okay, sir. Thank you.
Okay. So everybody knows this, right? What is symmetric? What is transitive? What is reflexive? What is equivalence relation?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, please explain one more time.
Sir, please
This one.
review all
transitive.
this.
Okay,
Yes, sir.
I'll tell you once again. So the last session, whatever I explained, I'll come again. Okay.
Excuse me, sir.
Yeah.
I just want to ask one thing. The previous question which you just solved, it was from any graded assignment, or it was from the practice assignment, or it was just the activity question?
Yeah. So I'm not aware of that, but some of people are saying I guess it's almost similar to some graded assignment.
Okay.
Yeah, I'm not. Yeah, I've not seen that. Yeah. So.
Actually, I also have a couple of queries. Would it be good if I will ask it first here?
Yeah. So you can ask me after the session got in. Okay.
Yeah, sure. Thank you.
Yeah. Okay. So basically, we were in the last previous session also I've discussed about the relation part. Okay. So there are basically 3 types of. Basically 3. Other than that, you can skip that. So reflection relation you should be knowing. You should be knowing the symmetric and the last transitive one. So the reflexive relation, whatever I'm saying, just listen to that. So if you have some
background noise,
then you please mute yourself.
Please mute yourself. We are not able to listen.
Yeah, please mute yourself. Okay. So there are basically three types of relation that, and if you have a Cartesian product, okay, so please mute yourself, otherwise it will be very difficult for me. Okay. So let's, for example, you have some set S. Okay. So you were having some set S, and then you calculated the Cartesian product of that X process. Okay. So if you are calculating the Cartesian product, so all the element of the whatever the relation that you are taking out from S cross S, okay, that will be what do you call that subset of this S cross S itself. So whatever the relation you are taking out from the any this Cartesian product will be a subset of this. Okay. So let's, for example, you have a relation R, okay, on a set S. Okay, so its set can be given, anything can be given here, and you are taking out some relation R. Okay, now you have to check whether it's a reflexive relation or not. So there is only one statement. See, R is a reflexive, whatever the relation that is given to you, whatever the sets or the bigger relation that is given to you, and then you have been asked regarding whether it's a reflexive or not. What you have to check is, so you have R, the given whatever the set is a relation, is a reflexive relation if and only if for all the S. See, let's, for example, you have some set S, and that has the elements some 1, 2, 3, 4. Okay, so the Cartesian product, okay, what is the cardinality for? What is the cardinality of S cross S?
16.
Yeah. Okay, so that's like pretty simple. So this whatever the relation that is given to you is a reflexive if and only if for all the X. So this word is very important. Okay, you can't have only 1, 2 terms. Basically, it should be whatever the number. So if you have 1, 2, 3, 4, so for each of the terms, so each of the X that belongs to X, XX should be present. So let's, for example, you have 1, 2, 3, 4. That means in a relation, the given relation, if you have to check it whether it's a reflexive or not, you have to scan for all the X. So you can have for this relation X itself, you have 1, 2, 3, 4. All the 4 terms should be present in the relation R as XX. That means 1, 1, 2, 2, 3, 3, and 4, 4. Apart from this, there is no condition, right? So there is basically one condition, that is what? For all the X that is present in S, set S, XX should be present in the your relation R. Then only you can say that the relation R is a reflexive. Other than that, you can't say. So let's, for example, you have been given a relation. Okay. So let's, for example, you have a relation X S equals to A, B, and C. And then a relation R1, you have to check whether R1 is reflexive or not. And R1 given is what? A.
Indian root me.
Is this a reflexive relation?
दोपहर में दाल नहीं पकड़ा
Yes, sir.
या खेल
No, sir.
Yeah, sir.
It is.
Yeah, it is a
No,
reflexive.
sir.
It is reflexive.
Yes, it is reflexive.
What is the
That's
condition that I told you?
Other pair also coming to the set.
But AB is extra is there, sir.
It is not.
It must be a reflexive. It is must be identity relation.
Okay, see, what did I say about the reflexive? So R be a reflexive relation on set S if and only if there is only one condition that you have to check. If and only if for all X that is present in S, okay, XX should be present in R. Okay, so apart from this, if you have, see, I was having A, B, C. If I have A, B, B, C, C. Apart from this, anything else can be present. I don't have to worry about that. I just have to check for all X that is present in S, XX should be present. Okay, you can say, so you can check this, right? So X1, you can think of X1, X2, X3. X1 is A, X2 is B, X3 is C. Okay, and for all this X1, X2, X3, is X1, X1 present? Is X2, X2 present? Is X3, X3 present in R1? Is it present or not?
Easily. Yes, sir.
Yes.
It's present, right? See, I have started scanning. Okay, what did I say? If you have to check for the reflexive, you just have to go and see the S. Okay, the relation set S, the bigger set S, on which you have to check the relation is present or not. So bigger set you have checked. Whatever the elements is present in here, all should be present in the form of reflexive form. So for A should be present. For B
A and B
present.
can be.
For C should be present. Apart from this, anything else can be present. Okay. So let's, for example, this is R2, and here it has been given AA. Is this a reflexive relation?
No, sir.
Why not?
CC is not present.
No, C is not present.
All element is not present.
Yeah, correct. Is this clear to everyone now?
Yes.
Yes, sir.
Sir, I have a
Yes,
doubt.
sir.
Yeah.
In R1 relation, if AB is not present, only AA, BB, CC is only there. So does it mean it is also reflexive?
Can you
Yes.
repeat that in
Yeah.
R1?
Yes.
Yes, yes.
Yes, yes.
Yes.
Yes, yes, it will
It
be.
will be both identity and reflexive.
Okay.
Okay.
No, so
Is
my
this
question was
you're
if
asking?
my question was in R1, if AB is not present, only AA, BB, CC is there. So do we call it reflexive or identity?
It's a both.
It's
Okay.
both.
For reflexive, what did I say? Just only one condition you have to check. For all X belongs to S, X should be present in R1 or wherever you are checking the relation. Okay. Nothing else you have to check. Apart from this, you can have anything A, B, B, C, C, D. You don't have to worry, even though it's not there, because you don't have to worry about this. You have to worry about this, right? For all X belongs to S, XX should be present in the relation. Okay, then it's a reflexive relation. That's it, you have to check. Is this clear to everyone?
Yes,
Is
sir.
this clear?
Yes, sir.
Yes, sir.
Okay, now for the symmetric relation, you can see that. So can you tell me about the R1? It's a reflexive or not?
Yes, sir.
Yes.
If you have X
Yes, sir.
equals to A, B, C, D, is it
No, it is not.
R1 reflexive?
No.
No.
Yeah, if you have
No.
S equals to A, B, C, D, you can't say because DD is not present, right? So now it is a reflexive and identity, whatever you want to call it as. It's a, if you have R3, that is R2 plus some extra term also, then also it's a reflexive, correct?
Yeah.
Yes.
Is this clear to everyone?
Yes, sir.
Now come to the symmetric. See, so for a symmetric relation, R is a symmetric if and only if for every xy belongs to R, yx should be present. So now there is no condition on S. You just have to check the relation R. So wherever the relation that has been given to you, you just have to check whether in this relation, a given relation R, for any term in the form of xy, yx should be present. That is what you have to check. Okay. Did you understand that? So let's, for example, for S, 1, 2, 3, 4 was there. So I have just seen R1. You have to tell me whether R1 is a symmetric relation or not. Where 1, 2, and 2, 1 is given. Is this a symmetric relation?
Yes, sir.
Yes.
Yes, yes, yes.
Correct?
Yes,
It's a symmetric
Yes,
relation
sir.
because you don't have to worry about now S. You just have to worry about R1. Okay? If you have to worry about R1, you just have to see that for every xy, yx should be present in the relation R1. If that is present, if that condition itself is fulfilled, you can directly say that's a symmetric relation. Correct? Is R1 a reflexive relation?
No.
No, sir.
No,
No.
it's not reflexive.
Why did you take
No.
this much time? You just have to say directly, you can say, right? For reflexive, what was the condition? At least 4 terms should be present. At least, because you have 4 terms here, right? Okay, what about the R2?
No.
Is it a
No, sir.
reflexive?
No, sir. It's not very
No.
It is a
Four
symmetric
is
relation.
Symmetric?
sir.
Is it a symmetric R2?
Yes, sir. It is a
Yes,
No,
it is.
sir.
No, 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 no.
Symmetric.
Who is saying
It
no?
is symmetric,
Why
sir.
not?
It's symmetric.
It's not a symmetric.
Why?
Symmetric only, right?
Yeah, yes, yes, yes.
It is
Why not
symmetric.
symmetric? Symmetric, what did I say? For every xy, yx should be present. So for 1, 1, is 1, 1 not present?
Yes, sir. It's
For 2, 2, 2, 2 is present. For 3, 3, 3, 3 is present. So why are you like, it's a symmetric. What about the R3?
So it is not mandated that all the elements should be there. No,
Yeah,
it
what
should
did I
not.
say? For R is symmetric if and only if for every xy. That is what I was saying. You don't have to worry
Okay, if
about
there is
the
check,
bigger
then there
set.
should be a repeated set. Okay.
Huh. For symmetric, but for reflexive, you have to check. For reflexive, what did I say? For reflexive, all the term.
Condition on yes.
Yeah, all term is very important. This all is very important. So for a reflexive and only if for all x belongs to S, so the bigger set. So for all x, xx should be present. Okay. Apart from that, anything else can be present, but this is the minimum condition. If this minimum condition is fulfilled, then you can directly say that it's a reflexive. And for the symmetry, it's like pretty simple. For every xy, yx should be present. That's it. Got it? Let's move to the transitive. So for the transitive, yeah, this you have to listen carefully. For a transitive relation, R, whatever the relation that has been given to you, and you have to check it. R is said to be a transitive if and only if for every pair of element x, y, and y, z belongs to R, x, z should be present. So again, there is no condition on S. Okay, so you just have to check R relation, and you have to scan it from the starting. If x, y is present, if any term in the form of x, y, you have to check for the other term that starts with y. And if there is any other term that starts with y, you have to check xz is present or not. Okay. See, if you have some R been given
Can
to
you
you.
repeat the response, please?
I'll repeat
Sir,
it again.
please repeat.
I'll repeat it. So for R to be a transitive relation, you have to check. So whatever the condition, whatever the relation, bigger set has been given to you, you have to go through each and every element. Okay. First element you have to see if it is in the form of xy. You have to see on the remaining term whether is there any other term that starts with y or not. If it starts with y, let's for example this is yz. Okay. Then you have to check it for xz. If I'll again repeat it, if there is a term xy, you have to check any other term that starts with y. If it is present in the form of yz, then you have to check xz. If xz is present, then from point of view of xy, this is a transitive relation. But if xz is not present, then you can directly say that this relation is not a transitive. Okay. See,
Yes, sir.
Sir, what if only x and y present? X comma y.
If only x comma y is present, then you don't have to see for yz. It's already a transitive relation.
Okay, sir.
I guess you would have got confused. Let me repeat it. Okay.
I couldn't understand.
Okay. So you have a relation R. Okay. This is AB. This is BC. And this is CA. And then you have AC. Okay.
Sir, please mute the mic of
Can you
Aman.
please mute yourself? Yeah. Who is that? Please mute yourself. Okay. For this relation R, okay, I'll start from the starting. So what did I say? I said that if you have a relation R, and if the element is in the form of xy, you have to check whether is there any other element that starts with this y. Okay, that you have to check first. So now let's, for example, I have to do the experiment on this R. Okay. So now go through the first element. What is the first element? AB. Is there any other element that starts with B?
Yes, sir.
Yes,
Yes,
sir.
BC.
Yes, sir. BC.
This BC, right?
BC.
What did I say? If you are able to find any other element that starts with y and it is in the form of yz, then for sure you need xz. If xz is present, then from xy point of view, it is a transitive. But if you are not able to find xz, then you can directly say that this whole relation is not transitive. Okay, this is the first condition that you should be checking. So again, come to this example. See, AB is there. You went and started scanning for any term that starts with B. You came with BC, right? Any other term you are not like no any. So BC is the only term. Now, what did I say? If you are able to see YZ, that means BC. That means AC should be present. Is AC present here?
Yes, sir. Present.
Yes,
Yeah.
sir.
If AC is present, then from AB, from if you are scanning from each and every term, so now this term itself has cleared you. This term has told that yeah, from my point of view, this is a transitive relation. Okay, this is a transitive. Okay, now come to this BC. Is there any term that starts with C?
Yes, sir.
Yes, sir.
This is CA, right? This is CA, correct? Now, which term you need? Which term should be present in this relation?
BA,
Which
sir.
term should be present?
BA, but BA is
BA
not
should be
there.
present. BA is there?
No, sir.
No, sir.
No, right? Then what did I say? If BA is not present, then you can directly say that the whole relation itself is not reflexive. Okay, if you are see, so this is the point. Even though if you are able to find one element according to that this is not transitive, you can directly say that this whole relation is not transitive. Okay, but from one like element, like if you are checking from one element point of view, if from AB it was a transitive, but the whole relation is not transitive, because from BC you can directly say that. So you have to find it one element from where you can directly say that it's not a transitive, then you can directly say it's not a transitive. One more condition is there. If you have a relation R and that consists of AB and this is CD, is this a transitive relation?
No,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
Yeah, it's a transitive relation. Why? Because what did I say? The condition is on if you are able to find XAB. So you have to check, is there any other element that starts with B? Is there any other element that starts with B? No, right? If there is no other element that starts with B, then you don't have to worry about other things, right? And again, so according to this element, it's a transitive. Now we go to see the CD. Is there any other element that starts with D? No. Correct? So now again, you don't have to worry about anything else, right? So every time you are scanning for the element, okay, if you are going through the first element and opting to see for any other element, right? Let's, for example, for AB, you were searching for any other element that starts with B. And if you are not able to find anything, you don't have to worry. It's like you can just go to the second term, right? Okay, so from this point of view, it's a transitive. Now you can go to the CD, and if again you are not able to find, so if let's for example you have 5 elements and you are not able to find anything in the form of whatever I said, X, Y, and Y, Z, you can directly say that it's a transitive relation. But if you are able to find any element that starts with B, then you have to search for AC. You got it, right? Is this clear to everyone?
Yeah, either
Yes, sir.
either full or void.
Yes, sir,
Like
it is
that.
clear. Huh. Let's solve some example. Okay.
Sir, one
Sir,
doubt, sir, actually.
Okay.
Sir, that AB, BC, that means if BC, CA, then BA should be there, then it is transitive. So, but C is not required, right? CA,
Okay.
then AB, then CB is not required, right?
Okay. I'll give you example. So let's, for example, this is S, this is A, B, C, D, and then we are making some relation R1, and R1 is this one, A, B, B, C, C, A. Okay. R2. Okay, now tell me whether R3 is a transitive relation or not.
Yes.
No,
Yes,
sir.
yes.
No, sir.
Not. It's not.
Yes, sir.
yes, sir.
Yes,
See,
yes.
It
Yes.
is.
let's start. Okay, let's
Yes,
start
sir.
solving this. What did I say for
CA must
transitive?
be there. So
Okay.
it will
Okay. So whoever has a doubt, I'll just clear this.
Not transitive.
Let's, for AB, any relation, what did I say? You just start with the first term. For AB, you search for any other element that starts with B. Yeah, you can find it, BC.
Yes.
What did I say? If you are able to find this, then AC should be
C.
present for sure. AC is present. Okay, now from AB point of view, this is a transitive. Okay, fine. Now come to BC. Is there any other element that starts with C? No. Anything that starts with C? No. So if there is no element that starts with C, then you can directly say that from BC also this is a transitive relation. Okay. Whenever you are able to find, then only there is the other thing to do. If you are not able to find anything, then it's fine, totally fine. Okay. Now again come to AC. Is there any other element that starts with C?
No, sir.
No.
No.
No, sir.
Again, you are not able to find it. Then again, from here also you got the clearance, right? So now from AB also clear, BC also clear, AC also clear. So this is the transitive relation.
Transitive, yes, sir.
Is this clear to
CA must
everyone?
be there, no?
Sir, for transitive, we have to
Yes,
check
sir.
for every pair, and even if got the one pair which is not transitive, the whole set will be not transitive.
Correct. Yes, sir, that is correct. Okay. Now tell me, what was your doubt? Who said? Is there any other doubt in R3?
No,
Sir,
sir.
in the ordering of the
Right
third
down
pair,
C,
there is no compulsion that C must be
Sir, R1 is
first
not
place.
transitive.
So R1, I'm not talking about R1 and R2. I'm just talking about R3. So if you
Sir,
have
I
any
am
doubt in
asking
R3,
that
you
in
can just ask
R3.
me.
Sir, I am asking that in R3. In the third pair, there is no compulsion that C must be in first place and then A.
AC should be. You can't write it CA, right? Because order is important in relation. I told you, right? For set, the order is not important. For relation,
Yes, sir,
set
that's why
order.
I am asking that the third pair must start from C and then A.
Third pair must start with C and A. I am not able to understand this.
Third pair, sir, the third element. The
Sir,
third
can you
element
move to equivalence relation?
C, comma A to be transitive.
Okay, to be a transitive, it's a transitive already, right?
A comma C is also.
It's XY, YZ, and XZ, not ZX.
C. For A, C, what do you need? Any element that starts with C? Is there any other element that starts with C? No. Correct? So this is fine. For BC also, there's no element that starts with C. That is fine. For AB, this element starts with B. Correct? So if there is an element that starts with BC, then you need what? You need AC. Correct? And AC is present. So it's a transitive.
Okay, sir. Thank you.
Got it, right? Yeah. So let's, for example, if this was not present. Now, can you tell me whether it's a, if this just AC and BC, is it transitive?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Sir.
Yeah. So now you got it. I guess you're able to understand that. So now you can
Yes,
tell me
yes,
about
sir.
the R2.
Yes, sir. It is a transitive.
It is transitive.
It's transitive. What did I say? For AB, no any other set like element that starts with B. If there is nothing, you can directly say that. What about the R1?
Not
No, sir. Not, sir.
Not
Not, sir.
Not transitive.
AC, you don't have. So directly it's a not transitive. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir. Move to equivalence relation, please.
Which one?
Sir, how do we solve those questions where the relation is given A minus B equal to 2 and we have to take the correct option in which it is given if it is a equivalent relation or is it a function? How do we solve such questions?
So I told you, right? So here also, so there is something, right? So you have to first build R1 and R2, whatever the relation is given. R1 is if it's a given relation, you have to first build the R1. So whatever the condition is given, you have to just write the R1 explicitly. Okay, then only you'll be able to see whether if you're not able to write R1, so the relation itself, then it will be very difficult. Okay, first write the term, all the elements of the relation, then only you'll be able to justify or tell whether it's a symmetric. So if it's a equivalent, that means it should be all the three: symmetric, reflexive, and transitive.
Okay, sir.
Okay, let's come to this. So
I
you
have a
have
question. What if the relation is like extremely long?
What?
Like, what if the relation is like extremely long? Like, it has a lot of numbers, which cannot be written everything like a lot of numbers.
See, let for example this question itself. Let A be a relation defined as AB such that AB lives in the same city. Okay, here you can't write, right? You can't write all the elements of a city. State whether this is true or false. Is it a symmetric relation or not? Just
Yes,
think
sir.
for some 30 seconds and then.
Yes, sir, it is symmetric.
Yes, symmetric.
Symmetric.
What is the definition that I told you for symmetric?
If A comma B belongs to R, then B comma A must belong to R.
Correct. So if two peoples are there living in the same city, can I say if AB lives in the same city? Can I write it like this also?
Yes,
What
sir.
does this mean?
Yes, sir.
Yes, sir.
Same city?
Yes,
B and
sir.
C.
We can.
Is there any difference? No, right? So that's what getting the relation R. So if AB is present, then BA must be present there, right? Correct?
Yes, sir.
See, if AB lives in some place, same city, let's for example Delhi, so you can directly say that BA lives in Delhi, right? There's no problem in that. So this like a this relation itself that from direct you can directly say that it's a symmetric relation, correct?
Yes, sir.
Yeah. Think of this question now. This one. If R be a relation that is defined here, AB lives in state whether it's a transitive relation or not.
Yes, sir. It is also
Yes, sir.
transitive.
Yes,
Yes,
sir.
sir, it is.
Can you give me one example if somebody okay and whoever is not able to solve, you can just ask me the doubt, okay? If you are not able to.
Sir, I have a doubt.
Uh-huh.
It's something else. If there are three elements and it's fully transitive, that is, relationship is totally transitive, what will be its cardinality? I'm just curious.
What I'm not able to get that point.
If there is a three element set, three element S, and the relationship is a transitive relation set, R is a transitive,
Okay.
then what will be the cardinality of R?
Hey, R, the number of the values can be anything, right? Anything, I mean, see, I gave you one example. There was a Cartesian product, ABCD, correct? Okay. I can write a lot of relation where the relation R will be a transitive and just mix can take, let's for example, this is AB. This itself is a transitive. I can take a relation R here, AB, BC, and AC. This is also transitive, right? So here the cardinality is 1, here is 3, right?
Okay.
Got it, right? There must be some other condition also to solve that. Any questions where the cardinality is been asked. Because from one Cartesian product, you can get a n number of sets, right? If the element is there can be something else also. Yeah, now tell me about this one. R is a transitive or not? If it is a transitive, can you tell me how?
Yeah, if A lives in A and B, C lives in the city, then A will be related to B and B can relate to C, then A can relate to C.
Correct.
There is no C here actually. A and B is there means there is nothing starts from B, right? So it can be directly.
No, it's like I guess you got but the answer is correct. But see, let's for example, you're just taking out some random people. Okay, let's for example AB from the Delhi itself. Okay, and let's for example B and C also lives in Delhi.
Then A and
That
C
means
also in Delhi.
then A and C also will be in Delhi, right? So this is what happens. So this is simple. Now come to this question. Come to the function.
Sir, one question, please.
Yeah.
Can we call empty set as the transitive?
Which set?
Or not? Empty. A relation with the zero element.
Okay.
Nor phi.
Null set.
Okay, empty set is a transitive or not? This is what you are asking.
Yes.
If you have, you can I like you can say that it's a transitive also because there is nothing in that.
Means whether it will lie in that category or not.
Yeah, it will lie in the transitive category.
No, but we do not define transitivity on set, right? We define it on a relation. So first we have to find the relation.
Is also
that the
a
null
group
set
of
has,
elements.
right?
Relation is also a group of elements, so you can call a relation as a set.
But relation is defined on a set.
Relation is a group of elements, and
relation is not
what
a
we
set.
call a set.
Relation is on two sets.
This is not a discussion.
Okay, see. 1 second. It's like a very arbitrary like question. You can say, or you can say that it's an empty set can be empty, like there is no relation itself. Like there was no relation, right? This is what you are saying. So you have some Cartesian product of some set, bigger set, and then you are having some relation, and that itself doesn't have any element. This is what you are saying, correct? There's nothing in this, right? So there was no relation itself. So there is nothing. So whatever you want to call that, you can call this, but there is nothing inside that. So I don't know. Like I need to check.
Yeah, that's the same. I want to know whether it will lie in that category or not. Should we consider in that direction or not?
I need to check this because I didn't think of this problem as a like. What are you going to say if there is nothing inside a relation itself?
No,
I'll check it and then
the
I'll
relation cannot be of null set. It has to be.
check this. Okay. I'll check
One
this and
to-
I'll get back to you in tomorrow session.
Sure. Thank you.
In the same example of A and B lives in the same city, can that be an equivalent relation because it will be transitive, symmetric, and reflexive also?
Yeah. It can be.
Hello.
Yeah. It can be equivalence relation also. Let's come to the function. I'll discuss. We have some about what?
Let the function first.
So let's discuss. Okay.
The absolute function, please.
Okay, can you tell me whether this is a function or not? Is this a function?
No, sir.
Yes.
No, sir. You tell me. How does this
Is
a function?
Yes.
Yeah.
Yes,
sir.
sir. It's a function.
B is a function.
Yes, sir.
Which of them is a function, A or B?
B is a
B.
function.
B is a function because so you are
Sir,
correct.
Raman is spamming here. Please remove him.
Who is that?
Okay, so hello.
So you are correct. So B is a function, A is a function.
Can you please explain a little bit on that?
No, can everyone mute, please? I think people are talking, cross talking.
Please mute yourself.
Please mute the mic.
Yeah, you can mute them otherwise.
Okay. So let's come to that. What I was discussing, function I was discussing, right? So basically you do, are you aware of this? Like basically you'll be going through the function, injective function, bijective, everything again in the 5th week. Okay. So here you just have to get to know the basic stuffs. Okay. The basic things. If you are able to know about the injective, bijective, surjective or not, that's it. So the very basic functions will be there. You will not be asked any difficult functions. Okay. Because again, you'll be taught all this stuffs, all this content are there. Again, you'll start it from after this qualifier paper. Okay, this injective, all these things again will be taught, but there will be taught in a very like the whole week itself will be on the function itself. So you'll be having some 3-4 weeks of content all together on the function, calculus and differentiability, everything. So you don't have to worry if you're not able to judge about the injective, but okay, so the little bit idea you should be having. Okay, what do you mean by injective, and then what do you mean by this all 3 functions? Okay, surjective and bijective, that is what you should be aware of that. Anything else you should like, if you have to say like quadratic equation, then you should be knowing, okay, for a quadratic equation how can it be an injective function, because for 2 values you'll be getting some, if it's a quadratic and if you are able to get the roots, then you'll be having some 2 values from where you'll be getting some 0, like, right? So because it's a quadratic, then most probably it will be having 2 root. Those type of things you should be knowing. More than that it's not required, at least for this 4 weeks. After that you will be taught about the extended version. Okay, we'll be going through all the other functions like log and then exponential.
How many chapters will be covered, sir?
What?
Up to this 4 week, how many chapters will be covered?
After 4 weeks,
how many chapters will be covered? Like we have covered in week 1 the function and all this. So up to 4 weeks, how many chapters will be completed?
Up till 4 weeks, you have like this basic stuff of second theory, and then you'll be taught the straight line, and then you have quadratic equation and the polynomial. So till polynomial will be taught, and then after that the calculus part will start. All this function
So this
stuff.
quadratic equation also is not there in week 1, right? I mean, I did not see anywhere.
Week 3, it will be there in week 3.
Week 3, right? Okay. We are in week.
Yeah, so you are in week 1 and 2. Week 2 is like straight line, and then all the things are simple. Polynomial a bit you have to go through that, and then everything else. So let's come to the function. I guess like this is what I was saying. Okay, so this won't be a function. This is not a function. This is a function. There you'll read it again in the week 5 that there is some horizontal test and then vertical test. Okay, so if you have been given some plot, you can directly say that it's a function or not, right? If you are just plotting a vertical line and it crossing only one time through the function of the graph that has been given to you, you can directly say that's a function. Okay, and if the horizontal line that you are dropping, if it is not, then you can directly say that's not a function. Okay, so here you can see that for this graph, okay, you can see that if you are dropping one vertical line, it is crossing at two places, right? So that's why you can directly say that's not a function. Okay, because for one value you are getting two outputs, right? Two mapping you are doing, so that's why it's not a function. But this you can directly say that's a function. Again, there is a horizontal line test also. Okay, horizontal line test also to check whether its function is 1 1 or not, but that you will be going through in the week 5, so no need to worry about those things. Okay.
There was a question asked if there is a relation a minus b equal to 0, and it was asked if the relation R is a function, then how will we know if the relation is a function or not?
So for that you should be knowing that what is the can you write the relation R? If you are able to write the relation R in the form of xy, you can see that this can be your one mapping and this is the other mapping. Okay, and then from there you can get an idea whether it's a function or not. Okay.
Okay.
What did I say about the function? What did I say? For one value, you should not be getting two map value, right? So this is what I told. See, for one x, you should not be getting two y, right? If it's like this is what a graph where if you are dropping a vertical line here, or let's for example, you're dropping a vertical line here for this x value x1, you're getting y1 and y2, right? This should not happen. So for a function, it's pretty simple.
So y equal to root x is not function. Y equal to root x is not a function.
Y equals to x.
Root x.
How do you plot the
It
function?
depends on the domain.
It is function.
Y equal to root x.
See, what did I say? Okay, I'll plot that. See directly y equals to root x. Okay, sorry. You can plot that function. If something goes like this, right? If this is something like this, what did I say? If you are dropping a line here, is it crossing more than one time or only one time?
Like if you are taking both positive and negative value of root x, then
you can't have negative. It will be imaginary then.
Don't be then it will be an imaginary number.
That is for y is equal to x square, not root x.
Root x only he asked, right?
Okay. Got it. For each value of x, there should be one value of y.
Yeah.
But if my x is 9, then y cannot be plus minus 3.
If you are putting x equals to 9, how can it be y be your minus 3?
Because minus 3 square is also 9.
Please mute yourself.
See, if you are putting
minus 3 square is also 9.
Please mute yourself first of all. Okay. If you have y equals to root x, what is the domain of this function?
Real numbers.
Real numbers?
Number greater than.
Can you put x equals to minus 3 here?
Yeah, please mute yourself.
can you put, okay, if you have x equals to, sorry, y equals to root x, what is the domain of this function? What do you mean by domain? First of all, tell me, what do you mean by domain?
Input values.
The input values we can put in
Range
the
of input
equation.
values.
The input.
The
Can you
value
put
in
here
which,
x equals to -9?
sir, the value in which
No,
the
sir.
function is defined.
Will become complex number.
The value
Correct.
in which
No,
function is
X can
defined.
be 9. X can be 9. But as far as the mathematics I know, root x can be plus, root x value can be plus minus ab, whatever. Root
But you
9
can't put it.
is equal
No,
to
the
plus minus
domain
3.
is natural. Domain is an integer. Or
Domain, you can't put some negative values, right?
Sir,
Okay.
domain is the value which will give us a defined value.
Correct.
In if you
Then
ever
if you
input as
are
a
plotting root x, right? If you are plotting root x, I can't. Please mute yourself, everyone. Otherwise, it will be very difficult for me. Yeah. Okay. So what I was saying is, for any function, if you have to check whether this is a function, if you have been given a plot, directly you can check that. For one value, you should not be getting some two mapped value. Okay, if you are getting that, means it's not a function, first of all. Or if you have been given a plot, you can directly plot a vertical line, check that directly. And for one also, you check it with the horizontal line, but that you have not been taught, so you don't have to worry about that. Okay, is it fine?
Yes, sir.
Yeah, this is what. So yeah, and basically this is the horizontal line test that you do for one function. If you have been given any function, and if you are plotting any horizontal line, if that function, if that horizontal line is cutting the plot that has been given to you at two places, you can directly say that it's not a one function. It should be cutting at only one point of, like, one point. That's it. If it is cutting at only one point, if you are dropping some horizontal line, okay, and if it's cutting at only one point, you can directly say that it's a one function. Okay, to check that, there are so many other things too. If somebody will ask
What
you,
about onto?
Okay, onto is what? How do you call the function onto?
Codomain should be equal to range.
Codomain should be equals to?
No, unpaired.
yeah, every value in codomain should have a map value in domain.
Yeah, it's like basically the codomains will be equal to the range. Okay, so this is
Sir,
how
can you explain that by solving a relation?
Okay, I'll do that. First of all, for the injective function, if you have been given a plot, you can directly get it, right? Everybody will be able to solve that, right? If you have been given the plot, okay, you can directly drop a horizontal line to check it is whether it's an injective or a one function or not. Okay, is this clear to everyone?
Sir, I have a doubt actually. So when it comes to injective function, we have to go for the horizontal line test, right? So we're not
Horizontal line test, you can do that. Okay, you can do that, but if you have been given the plot, but you have not be given any plot because you have not been taught yet. So in questions, yeah, whatever will be asked in the quiz paper, there won't be any plot, and then you'll be asked whether it's injective or not, because all those things will start from week 5. Okay, so all the basic things will be asked only, not any like fancy things won't be asked. So everything that will be taught from week 5, those won't be asked. So for the injective also, will be just given some mapping or some simple relation or something like that. Okay, there won't be any graphs and any difficult functions will be given because you have not been taught yet. Okay, those things you can directly see. If you have an increasing function or a strictly increasing function, you can directly say that's a one or strictly decreasing. But the increasing function, decreasing function, all those things has not been taught yet. So we just expect you are not, like, many of you are knowing that, but okay, many of you are not also knowing. So everything, whenever will be taught from week 5, then only will be in the position to predict or to tell about the given function, a bigger function or a difficult function. For now, you should be just knowing a quadratic function, a simple function. Okay, so those can be directly put it with the help of some random hit and trial method. Okay, is this clear to everyone?
Yes, okay.
Yeah, so no need to worry. You should be knowing just the basic things. Like here, it has been given the injective function. So can somebody explain you what is injective function?
Yes, sir. If every element in a domain has a unique element in the codomain.
Correct.
And
So every element, if you have some set x and y, and you are doing the mapping, or
codomain is equal to range.
yeah, so from domain to codomain. Okay, if each element in set A or set one set that you have made, the X set is mapped to a distinct element. Okay, so here everything that's been written in one word. See, one to many is not should not be there. One to many is what? One to many. If you have one to many, what does that mean? Is it a function or not?
It's not a
No.
function.
Not a function at all. One to many is not
No, no.
possible. One value, if you are getting too many values, that
No,
will
one.
itself it's not a function, right?
Yes,
For
sir.
yeah, so
But
for
two
this
element can have a
for
same
what?
two element in a domain can have same image in.
That is a function. That can be a function, but that is not a one-one function.
Yes, sir.
Okay, many to one, again you can see that many to one is not possible in injective, and one to many is also not possible. One to many is not, if it's one to many, that means it's not even a function. Okay, and if it's a many to one, you can say that it's a function, but it's not a one-one function.
Yes, sir.
Okay.
Yes, sir.
It's one to one.
This is basically one-one function. Yeah. Okay, and surjective is simply the range should be equals to your range. What is the range? The exact value that you are getting. Okay, and covert domain is like the whole set of the other set. Generally, you put it. Okay, I'll tell you. I'll show you that. Okay, and the bijective is injective and surjective, like one onto both. Then you can directly say it's a bijective function. So this is not important for you. Okay, can you tell me this all things? Is it a function? The first one?
No.
No, sir.
No.
Sir.
No.
No.
Because
Why is not a function?
It is a function, but it's not
Values
injective.
1 and 2.
One to many.
Yeah, this is one to many. And what did I say? One to many is not possible. Okay. Is it a function? Is it a function?
One to one. Yes.
Yes, sir.
Yes, yes.
It's a function.
Yes, it is an injective function.
Is it a one-one function?
Yes,
Yes.
sir.
Yes, sir, it is 1-1.
It is 1 2 on 2 also, no?
It's bijective. Codomain is not given.
Yeah. So okay, what do you? So this is basically the domain of a function. This is a codomain, right?
Can you mute this, please?
And two also.
Yeah, I don't
Somebody's
know.
mic is
I don't know who is that.
Yeah, I guess now it is. Okay. So is it a one-one function?
Yes, sir, it's a fun one.
Is it a onto function,
Yes,
like a surjective function?
No, it's injective.
It's an injective, that is fine. Is that surjective function? Surjective, like the codomain, is the codomain equals to domain?
Yes.
Yeah, yeah.
Yes.
Yes,
Codomain
it
equals
is.
to range.
It's the right
This is a okay. Yeah. What can I do now? Like it's like. So codomain. Okay. What do you? So for this function, what is the codomain? 1, 2, 3, 4. What is the range for this function? The
1 2
relation
3 4
1, 2, 3, 4.
1, 2, 3, 4.
So the codomain is equal to the range, right? So if range is equals to codomain, what do you mean by that?
Surjective.
It's on 2.
Surjective.
So onto function.
Surjective function, right? Correct?
Yes, sir.
Is a bijective function? Is a bijective or not?
Yes, sir.
Yes.
Yes, sir, it is
Bijective.
bijective.
Yes.
The bijective function, right? Because it's fulfilling all the condition. 1 also
On
plus onto also.
Onto also.
Yeah. Can you tell me about this function?
Yes, sir, it is a function, but
It's a
it is not
function.
injective.
It's a
Onto.
Tell me about first. Is it a function or not?
It is a subjective.
Yes,
Sir, it
sir.
is a
It is.
subjective function.
It is
Not
subjective.
one
Onto function.
Is it a function? This is a function, right? This is a
Subjective.
function first of all. Is the one function?
No, sir.
No.
No,
Not
sir.
1, 1.
Why?
Because they don't have
It's
dictionary.
many to one.
D and E, right?
We have
So
both
for
Because D and E don't have the unique element.
correct. So for 1 you already
Not
know that
1 but onto.
1 to many should not be present, and many to one also should not be present. Both should not be present. Correct. So this you can see that for D and E you have only one project like mapping 4. So it's not 1 1. Is it onto function?
Yes, sir.
Onto.
Yes.
Yes,
The
sir.
surjective, right? Why? Because the codomain and the range for this function itself is same, right?
Yeah.
Can you tell me about this function, the last one?
It's not
It is
a function.
and
It's
First tell me, is a function
Codomain is not equal to
1
range.
1?
Can explain the last
It's
one
just
first?
One
The function.
One
a
one
only
fun-
It's
function.
a function and one, but not onto.
One.
This is a 1 1 1 1 2. This is
not
onto or
onto.
not?
No,
No.
sir.
No,
We can
No,
say that codomain
Not on to.
No, sir.
Not
it's
equal
not
to
equal
range.
to range.
Codomain is not equal
not
to
equals
range.
to range. Okay. Now come to and let's solve some problem here. So I have discussed all the things. Yeah, tell me about this function. Is this a one? Is this a 1 1 function? So you have to take 1 minute. Try to solve this. So everything I've explained now, 1 1. For 1 1, you have to check it should not be many to 1 and 1 to many. Okay. So for this type of function, you just have to pick out some random two values where you are getting the same output.
Not 1 1 function.
Not 1 1.
No, it's not one to one.
Not
No,
to function.
not one.
One.
Okay, if this is
No,
not
sir.
1 1, can you tell me the values for which you are getting the same mapping?
1
2
and
and 3.
2.
1 and 2.
1 and 2,
One and
3
two.
and
If I am
4,
putting,
1 and
and
2
for
6,
example,
and 3
7
and
and
please
8.
mute yourself.
Many.
Like
There are many.
if you are, I don't know from where the noise is coming, but please mute that. So if I'm putting n equals to 1, you can see that the function value f1 will be equals to what? 1 plus 1 by 2. This is 1. And again, if I am putting n equals to 2, what is the value? f2 equals to 2 upon 2. Hey, and what should I do? Okay, so for this also you are getting the same thing, right? So now you can see that for two different value, what is this? Many to one or one to many?
Maybe one.
Many to 1.
Many to one.
Many to 1.
Many one, sir.
Many to one.
What?
Yeah. So if this is many to one, is this a 1 1 or not?
No.
Not 1.
No,
No,
sir.
sir.
Not 1.
No,
No,
sir.
sir. In one more.
Okay, can you tell me what is the domain of this function that has been given to you? Where is the
Natural
domain?
numbers.
Natural
All
numbers.
All natural numbers.
All natural numbers.
Zero to
All
And
natural number minus 0.
And codomain
what
does
is the
not
codomain?
Also same thing.
Is also all the natural
All
numbers.
natural numbers.
Same.
Natural number.
All the natural numbers, sir.
Correct?
So shouldn't we exclude 0 from domain because it would be 1 by 2?
What?
Shouldn't we exclude 0 from the domain?
Why?
For 0, it's
Uh,
even. N is even, right?
0 is even, no?
A
Yeah,
zero,
but
you can say anything like, yeah, mostly
It is not odd.
the book
0
take
by 2 is 0.
usually the book take it as a even number, but okay, it's fine. So, but yeah, it's like, so you have to take 0 also here.
okay,
Because it's given natural number, right? So natural
okay,
number, you have to
fine,
0
fine.
to infinite.
Fine.
Okay.
Sir, it is onto or not?
Yeah, check it onto.
Yes,
Yeah,
it's
so I think it is onto.
Because see, if you're for some or other value, you'll be able to get all the numbers, right? Correct?
Sir,
Yes,
can
sir.
you explain that once again?
Okay. See, let's see. So I told you the domain for this function, and see for checking one function, what did I say? You have to check for many to one. If you are putting many values, for many values, whether you are getting one values or not. If you are able to get, even though if you are able to take some two values from the domain, so D1 and D2, and for these two values itself, if you are able to get some only one mapped value. So this is many to 1. Okay, let's for example this is some y1, and if you are able to get this, you can directly say that this function is not 1 1, right? So what did I do? I just took n equals to 1. So you just have to take some two values. For those two values, the output is same. And if this is occurring, you can directly say that it's not a 1-1, because I already told you, right? If you are plotting a vertical line, it should just cross only once, okay? Or many to one is not possible. It should be for one, from one domain, it should be mapping to some distinct codomain values, right? So here again, if you are putting n equals to 1, it's an odd number, and f1 is what? 1, correct? 1 plus 1 by 2, so this is basically 1. And again, if I am putting n equals to 2, so f2 is also what? 2 upon 2, this is 1. So you can see that for two different values, I'm getting the output as 1 only. So that means what? Many to 1. So this is not a 1-1 function.
Okay,
Correct?
it's on to not
So
1-1.
this equation will
Thank you,
always
sir.
give us that like rational numbers, that n plus 1 by 2 and n by 2.
What? N plus 1 by 2 and?
N by 2 will always give us that rational number now.
Yeah, it will always be giving you, if you are putting some values, it will always be giving you some rational number values. How can you get some irrational? Because itself, the domain itself is natural number, right? So if you are putting some natural number like from 0 to infinite anything, you'll be getting some values in the form of p by q, right? So it's not a 1-1 function, correct? Let's move to the next part. Yeah, tell me about this function. This is 1-1 or not? Just think of this, take out some two values you have to take, okay? If you are able to take out some two values, you can directly say that it's a 1-1 or not.
Not, sir. Because
No, sir, it's not.
No, sir, it's not
No,
1-1.
sir. It's very
What is
important.
the domain of this function?
It's
Natural
all
number.
natural.
What is the codomain?
All real
Real
numbers.
Numbers.
Okay. Can you tell me two values? Let's, for example, just take if
3 and
n equals
4.
3, sir.
to
3, sir.
3.
3,
If I am
4.
taking n equals to 3, what is the value that you are getting? 4. If I am taking n equals to 4 here, what is the value you are getting? 2. Here also you are 2. So you can see that for 3 or 4, both are mapping to 2. That means again many to 1.
Yeah.
Many to 1 means what? It's not 1-1, right? So this is again no. Correct?
Yes, sir.
Yes,
Let's
sir.
move to the next question. This is the final question, and after that, this is the final question. So you have to tell me the domain for this function. Okay. So domain for this function.
f of x equals to root x.
Okay, and just wait for 2 minutes. You have to solve it, and then only so nobody will unmute and say anything. Everybody should try to solve this question. This is an important one. You can get a similar question in the exam also. Okay, not that similar type of questions can be there in your paper also. So you just everybody should try and solve this question.
Sir, it's B option.
So option number B.
Sir, is the option B.
Option B, sir.
Option B.
Okay.
Option B? कैसा है option?
Tell me the domain of this function.
R.
What is the domain of this function?
Real values. Real numbers.
Real.
All real except
Real greater than -3
greater than -3.
except
Greater than
5.
All real number
Except 5.
For
greater than and
any
equal to
square root
5.
function, right? If you have to calculate the
positive
domain, how will you
number.
calculate? Because this can accept only positive values,
Only the
right?
positive values.
Yeah.
That means
Greater
x
than
plus
or
3
equals to
should be
0.
greater than equals to 0. What is the
Greater
value?
than
X
equal
greater
to
than equals to -3, right?
Yeah.
Correct?
Yes.
What about the
Yes,
domain
sir.
of the denominator part?
X not
And
equal
the
to
denominator
In
value
order
of
x minus 5 does not equal to 0. X equal to 5.
r minus 5. Correct?
Yes, sir.
Yeah. So you can directly say that all the values greater than -3 except -5. Right? I guess.
Please.
Sorry, plus 5.
Can you explain once more? Sorry.
Sorry, can you explain once more?
Okay. Let's. So please mute yourself. Okay. So if for any function, if this is function in the form of some px upon qx, if you have to calculate the domain, first thing you have to check is this qx should not be equals to 0, because if qx is equals to 0, that means the function itself is not defined. Okay, so you have to take out all those values of x where the function value is 0. Okay, function value, I mean the denominator part is 0, so those value you have to exclude. Okay, so again you can see that you can directly convert this function in the form of px and qx, where qx is x minus 5 and px is x plus 3. Correct. Now the function, so basically the domain is all the values that you can put it in the function, okay, for which the function is defined. You can't put any value of x where the denominator part gets 0 and the function is not defined. So that's why I have to remove those values where the function is not defined. Okay, which are those values? You can see that for the denominator part, x minus 5 not equals to 0, that means x should not be equals to 5. So this is the first thing that I have to exclude. This should not be there in my domain because I can't put 5. If I'll put it 5 here, so the numerator part to it is fine, but the denominator part will become 0. So this should not happen. Okay, that's why I have to exclude this one first of all. Okay, now the second thing is I have checked everything for the denominator part, but I have to check for the numerator part also, right? For the numerator part, I have to take out all the values for which the function is defined. Okay, so for any square root function, I can take only this value can be positive only. I can't take it minus 8, right? Because this will be a complex number. And again, it's not in like what are the real number that has been, so it will always be a positive. Okay, first of all, that should be there. So for this function, x plus 3, this x plus 3 should be positive. Okay, so now you can get it x equals to greater than equals to minus 3. So this is the values, these are the values. So all those values x greater than equals to minus 3 is defined for this numerator part. Okay, and now again there is a from the denominator also. So x equals to 5 you have to exclude. So that's why I'm doing the minus. So minus 5. So all those values here, that is satisfying this one, but except 5. Okay, basically the intersection, because you have to take care of all those values. Okay, so that's why you have to exclude 5 here. Okay, that's why this is the answer.
So slash 5 means exclude, huh? I mean,
What?
I'm trying the B answer.
I guess
That
you're not
greater than equal to 3 bracket close.
What?
Hello, are you able to hear me now?
Yeah, I can hear
So
you.
what I'm saying is, I'm trying to understand the B option. I understood that numerator, that slash and bracket 5 is there, right? I understood that it
Slash
should not
is
be
minus
5.
basically. You have already written in the Venn diagram, right? This is minus.
Okay,
So whenever you have to write it R1 minus R2, you can directly write it like this also.
No, I didn't attend the last class. So.
It didn't happen.
So actually, as per this thing, the value will be minus 3, minus 2, minus 1, 0, 2, 4.
This minus 3, no, this is all the values except minus 3, except this 5. Except this 5, all the values you can take.
Okay. From minus 3 to infinity.
Minus 3
except
to
5.
infinity, yeah. So it's basically in the straight line, if I want to show you, it's like all those values minus 3. So from minus 3, all those values except this 5. This is not included. Everything else is included. Okay?
Okay. Got it. Thank you.
Sir, I had one question about if it is bijective or surjective, the function fx is equal to x squared plus 2.
So 1 second, just give me 1 second. Okay. Yeah. So is this done? Everything. So now I'm done with this questions. I guess everything is, yeah. Okay.
Sir, you did Venn diagrams, right? Last time, did you have recording or something like that for me to go through?
Last time means last session.
This is the first session I'm attending. So
Can you just explain me about the domain range and codomain, that part?
Sir, are these videos recorded again?
Yeah, these are recorded. These are all recorded. These are
Where these videos are
Please
available?
check the chat box.
Sir, this is the first session, I think.
This is the first
session you have taken.
I've taken one more session that happened, I guess, in the morning 7 to 9. Very less people was there. Yeah, I guess that
no,
was
you
on.
explained about the Venn diagram, right? Did you are you going to explain again sometime tomorrow or?
Tomorrow those session will be taken care by the TAs. Okay, but I'll be there for some time. Yeah.
Okay, because if you have taken on Venn diagrams, I had some doubts, so that's why I was asking.
Okay. Yeah. So tomorrow morning again, we'll meet and then we can discuss it. Yeah, I can just take some more doubts, or I have to go for the dinner also.
Yeah,
Sir,
can I ask the question now?
The question.
As you UIQs.
Hello.
Yeah.
So you told me that I can ask the question later on
Yeah.
in the head of the session.
Yeah. Tell me.
Can I ask now?
Mm-hmm.
It is regarding the function. Lecture 1.9 functions. In that lecture, it was mentioned at a place that relation is a subset of domain cross range. Can you please explain that to me?
Relation is a subset of what?
Domain cross range.
Domain cross range. Okay. Yeah.
Lecture 1.9.
It will be something like domain cross codomain, right? Okay. So this basically, see, domain, you can think of all the values that you can put it in a function, right? Okay. Let's, for
Inputs.
example, you have some function. Okay. So function is basically some relation that you are putting, and that relation is y equals to x square. Okay. So y equals to x square is a function, is a relation, right? So if you are taking, if you just want to write it in the form of a relation, you'll be writing in the form of
Sir,
domain range one.
sorry to interrupt, sir. Can you please give make me understand through example?
Okay, I'll give you an example.
It would be helpful. With the help of example. Yeah, sure.
Okay. So are you able to see my screen?
Sir, yes, sir.
Yes, sir.
Okay. Yeah. Let's, for example, this is a
Yes.
domain of a function. This is a domain and this is a codomain. Okay. Let's, for example, this is value A, not value A. This is the domain, and the domain is like 1, 2. You can put 1, 2, 3, 4, and that is some relation that you are putting. Whenever you are putting the value, this domain inside this is giving you some codomain or some range value, right? This is something like, let's, for example, some 3, 4, 5, 6. Correct? So whenever you are writing in the form of some relation, okay, so it will be what? It will be, let's, for example, this f of x equals to some x square, and this is not the codomain that you're getting. Let's, for example, this the codomain can be anything like 1, 4, 9, 16, 25, something you are getting. So this is the codomain. So what are the relation that you'll be getting? One is related, if this is a function, this is the relation that you have established. Okay, some x square, okay, or maybe some 2x relation that you have established. Okay, and if you are putting something 1 here, what are the value that you'll be getting? 2, correct?
2.
Right? So this codomain I need, so it will be codomain something where you'll be able to get the y, right? So that's why you can write it this domain cross codomain, right? See, for 2, 4, 6, 8 you are getting. So the other relation, if you are putting 2 in the domain, what are the value that you are getting? So this is some relation R1. That relation R1 is this one. This R1 is established on 2x, y equals to 2x. 2, 4 you are getting. Then you are getting 3, 6. Then you are getting 4, 8. Correct? Let's, for example, you are calculating D cross this CD. If you're calculating D cross CD also, you'll be getting something, right? This is 1, 2, 1, 4, 1, 6, 1, 8. Again, 2, 2, 2, 4. So this the relation that you have calculated will be a subset of this function bigger set, right? Did you understand? Got it, right?
Yes,
No,
sir.
sir, sorry.
Okay, yeah. What I was
That
saying
last
is,
part I didn't got. That 22 and 24 means what is that?
okay. See, this is one set. This is the other set. If you are doing the product of this, what are the values that you'll be getting? 1, 2, because you can do
1,
it
2,
with
2,
this.
4, 3, 6, 4, 8.
No, 1, 4 also you'll be getting, right?
Yeah,
Then
yeah.
1, 6 also you'll be getting.
1 2 1 4 1
Okay.
6 1 8
Okay, so
2 2
this
2
you
4
can
2 6
see,
2 8.
you can tell this as a set, some set S, some bigger set S, and whatever the relation that you have got, R1 will be something subset of S, right? Will be some subset of S. This is what has been told, right?
Okay.
Yeah.
Yes, yes, yes.
Sir, I also have one
Thank you,
last
sir.
question.
Range, sir. So what about range? Can you explain that
Sir,
also?
I
Like,
also have a question.
Yeah, go ahead. Which question?
Sir, the question was we have to find if the function is bijective or surjective, and the function fx is x squared plus 2.
Okay, fx square plus 2. What is the domain being given to you?
We have to find if it is bijective or surjective.
No, domain, codomain, what are the other things that are given to you?
It's simply given that it is real number and nothing else was given.
Dual number? I didn't get you. See, if you have been given nothing else was given, that means anything you can put it. This is from R to R, correct? So any value you can put it. What did I say about the injective function? What is the definition I told you about the injective function? Or
That
1.
it will be that every element in A will have a unique element in B.
That means many to 1 is not possible, right? Okay. And if you are putting it here, what is the value of f minus 2 and f of 2?
Same value.
They will give the same value.
You'll be getting 4. Here also you'll be getting 4. So this is this a 1 function? Because at minus 2 and 2 both are mapping at 4. I told you many to 1 is not possible in injective, right? So is this an injective function?
Yes, sir. No, sir.
No, right? Yeah, that's it.
But the answer was given that it isn't injective and it is also not surjective.
Yeah, so it is not injective, correct?
Yes, sir.
And
How
for the
will we get that it is not surjective?
Okay. What is the definition of surjective?
The codomain will be equal to range.
Codomain will be equals to domain. So what is the codomain here?
All real numbers.
Okay. And if you are plotting f equals to x square plus 2, how will you plot?
Positive quadrant.
All natural numbers.
It will be something like this.
Parabola.
Yes, sir.
Okay.
Yeah.
So okay.
Yes, sir.
Can this function get any values lesser than this value?
No.
Or any x?
No, sir.
Can? No, right? So that means what? Is codomain equals to domain? Range? No, right? Because this
No,
value
sir.
can't take. These all values it can't take, right?
so can you
Yes,
explain
sir.
about this codomain and range? I'm just confused.
Okay. Or if you are not able to plot this, you can think of
Sir,
in that way. See, anything if you
sir,
are
please
putting
take
here.
an example for that, for
See,
subjective.
fx equals to x square plus 2. So you can think of in that way that if you are putting any values of x, what are the values that you'll be getting as a y? Any value, even though if you are putting n minus infinite also, you'll be getting some positive value, right? Can you get any negative value from here? Can you get any negative value from this function?
No, sir.
No, sir.
And
No, sir.
always it
No,
will
sir.
be plus 2
Everything
more. Therefore, the codomain will not be equal to range. Yes, sir. I got
correct.
it.
Correct. Yeah, it's simple, right? Because you have to just check whether the
Thank you,
codomain
sir.
equals to range or not. Yeah.
I have
Sir.
an activity question, sir.
Sir.
Activity question, can you please ask the tomorrow again we have a 10 to 11 session. Okay.
It's a
Sir,
graph
where
question.
Sir,
is this
please.
video available, sir? This recorded video?
Yeah, this will be available. Yeah, recorded video will be there.
So where it will be available, sir? Like,
It's
where
on
shall
the
we access?
YouTube, on the YouTube IITM online degree. This is a YouTube channel, okay, and then you can search for maths one. There you can get it.
Sir, how can I
Fine.
get PDF,
Fine, sir.
sir?
Thank you,
This
sir.
PDF.
This PDF, okay, I'll upload this on the portal. In the
Sir, that was
supplementary
a
content, you can see this.
that was a graph question, sir. Like asking for domain and range from the graph.
Okay, 1 second. I just have to get all the mail ID, whichever was having a issue. Okay, I'll just write it somewhere. Just give
Sir,
me
will tomorrow's session be recorded?
what? This
Tomorrow's
session is
session
recorded.
will be recorded or not?
Tomorrow won't be. Yeah, that won't be recorded.
So tomorrow
So where can we get the PYQs?
Can you shift the timing about 2 hours?
Sir, about tomorrow's session, so we did not get any. I did not get any link for that. So will it be?
I'll upload it. That's not done yet. I have to do it after the session.
Sir, I can't
Sir,
attach
can you
my
shift the
Google
timing
Calendar.
by 2
Sir.
hours?
Sir,
What?
I can't attach my Google
Sir,
Calendar
can you
in my
shift the
mobile
timing
phone.
of the class by 2 hours? That is not possible. Like again, day after tomorrow also again you have a session. Do not worry. Daily you have a session. Almost daily.
Hello, sir.
Yeah, yeah.
Sir, I can't attach my Google Calendar in my phone, sir. What can I do?
Go to desktop mode in Chrome.
No,
You
no,
will be able
I tried it, but it can't.
use a laptop.
Yeah, bro,
Yeah,
I
make
have
sure to
ordered
use
it.
your laptop.
Yes, I
It
have
doesn't work
ordered.
on phone.
It may take some time to arrive, so that I am using mobile phone.
You can do one thing. You can go to your calendar and then the option. Then on the left hand side there would be the task. You have to include those tasks. There would be a check boxes of the task. You can just click those check boxes, and those events would be added in your calendar.
Okay, I will
Or
check
you
it.
can
Thank you.
always use a third-party calendar from Play Store.
Thank you. I will
Yeah, that's a different thing.
try.
Hello, sir.
Yeah, yeah.
Yeah, I wanted to ask. I could see around 5 practice assignments by around noon today, and after in the evening around, I checked and I couldn't see the rest. So
What?
I'm referring them. There were 5 practice assignments that were visible for week 1. So I cannot see them now. Actually, there were a good variety of questions, and I was referring them. Like,
But
can I?
now there are only 3 practice assignments, sir.
Hey, it was supposed you don't have to worry about the practice assignment because practice assignment I told you, even though there's only 1 or 2 practice assignments,
So won't it affect our bonus marks?
hey, that won't affect anything. I'm making assuring you that won't affect anything. You just have to submit 1 practice assignment, okay? And that itself is not will be counted in the marks, that will be counted in the end, okay? So in the other conditions, you just have to submit graded assignment nicely, okay? Practice assignment is just for the practice, you can submit it, okay? There's no problem in that, but the graded assignment will mark you for the marking scheme. But the practice, you have to practice all the questions, then only you'll be in the better position to solve in the quiz, okay? In the quiz you can see that many of the questions, you can see that even though if you are going to the previous term paper, you can see that many of the questions are from almost similar pattern, same level, almost similar concepts are there in the quiz, okay? So that's why it's good to practice all the questions, each and every question from the practice and graded and go. Yeah, this is what you have to do.
So is it possible that can you upload like few varieties of these questions from practice tests, like the ones that we don't have but other students have on their profiles?
No, all the questions are same. All the questions are same. Only some questions will be in the form of jumbled values and something like that. Okay. Like if you have for you are getting x equals to 2. For some people, it will be x equals to 4.
Okay, got it. Also, is there any book where you can like practice a few questions like to better prepare for a qualifier?
Yeah. You're asking something? I didn't get you.
Yes, what I was saying is there any book where you can practice like reference questions that
Book
will be
is
like
there, right? Book is already uploaded in the supplementary content. You have a lot of questions, I guess. You can practice from there.
got it. Thank you.
Yeah, it's there in the supplementary content. But see, I'll tell you